So I've been playing a lot of Star Technology recently, and I started noticing something. There aren't really any good ways to parallelize certain machines without toggle buses. The most common method right now is using a toggle bus blocking setup. If you've played GT&H, you probably know this concept already. It's basically using toggle buses to block inputs and control when items enter a machine. StarTech has fully adopted this, and honestly, it has become the meta. But I have been digging around trying to find something different, something that can match the simplicity of this approach, but maybe do it better, or at least differently. And I think I may have actually found something. And yeah, it's kind of funny. It includes a little bit of duck tech. Okay, so time to talk about the core limitations of the toggle bus blocking setup. At the end of the day, it is bottlenecked by how quickly you can actually detect and react to items inside the subnet. Everything depends on the detection, when an item is seen, when the toggle bus reacts, and when the next state is allowed through. And that introduces a hard limit. Your throughput is capped by detection speed, your switching becomes the bottleneck, and as you scale, the number of checks and recalculations explode. So instead of scaling cleanly, the system actually slows itself down, which isn't particularly amazing. Alright, now let's get into the logistics of this design. Everything here is built around how the pattern provider actually behaves, and once you understand this, the whole setup makes a lot more sense. So first, a quick explanation. A pattern provider can output from any exposed side. Let's test that with a simple setup. We'll place a chest, order a basic pattern, and as expected, the item goes straight into the chest. Now, if we enable blocking mode, the pattern provider should stop pushing if the inventory is occupied. And yep, you can see it stops. But here's where it gets interesting. If we add another inventory on a different side, suddenly the pattern gets pushed again. And this is the key insight. Blocking mode doesn't apply globally. It applies per output path, which means one pattern provider isn't just limited to one machine. It can drive multiple outputs at the same time. That is the core idea that this system is built on. So now that we understand the mechanic, let's actually build it. I'll also be setting this up in my current playthrough. I need to run 120 assembly lines, so I may as well make a video on it, and you'll get a little bit of a base to it as well. So first off, place your pattern provider on the main network and enable blocking mode. Then surround it with interfaces. Just the 4 cardinal directions is enough. After that, place wireless connectors on the diagonals, power everything with quartz fiber, and run cables around the setup. 1 wireless per interface. Okay, now on the assembly line side, things here should look pretty familiar. Here we want to wall share inputs so multiple assembly lines can share a singular point of entry. On the controller side, place a quadruple input hatch, then add an inventory connector from Tom's storage. This connector can link inventories in about a 15 block radius, and if you offset it up by 1 block, it can reach the full length of the assembly line, using the fluid input hatch as a bridge, of course. Next, place 2 storage buses, one on the connector and one on the quadruple input hatch, and enable report inaccessible items. This is really important. It allows the pattern provider to see inside the subnet and properly respect blocking mode. And there you are done. And because we're sharing the setup, you effectively get 2 assembly lines per connection. Now, time to scale the module. To maximize this, build out 6 more assembly lines and connect each one to a wireless connection. And just like that, you have a fully parallelized module. Clean, simple, and scalable. Here's where it gets crazy. If you didn't know, you could put the same pattern into multiple interfaces, and the system will push to all of them. So now, instead of 8 assembly lines, you can duplicate the setup and do 16, with a perfect blocking mode and no restrictions. Now, copying the patterns can be painful, but thankfully, there is a better way. using a memory card. Shift right click to copy the pattern provider, then right click another pattern provider to paste it, and you're done. But duck, how annoying is that? Every time I add a pattern, I have to bloody go around every pattern provider and copy and paste it. And you'd be right if you had to do it manually every time. But this is where things get really cool and I started to innovate. Automation with modular routers. Modular routers are kind of insane if you haven't used them before. They kind of blew my mind at first. They can simulate player interaction, including using a memory card. You will probably need to enable fake player in your chunk settings, but that's easy enough, anyone can do that. So here's what you have to do. Set up an activation module that shift right clicks to copy. Put your memory card inside the router, and this will store your pattern provider configuration. Then use another distributor module to pass the memory card to another router. In that router, use another activation module to apply the settings using a normal right click. Okay, so I'm actually live in game. I swapped over from a voiceover because I'm going to try explain how these cards actually work and how you need to configure them to work. So there's an issue with having modular routers directly next to a pattern provider because they will try push into the actual modular router. You are going to need some sort of item to stay there and cycle. So the solution that I came up with was to have a buffer modular router here and have your memory card stored in here. And you can put these activator and distributor modules on redstone augments and control them on a pulse, right? And this distributor module will be filtered for a memory card, whitelisted, obviously, and ignored MPT. And this is going to go straight into this modular router, which has an empty space and is not touching any of these guys. So this kind of acts as a buffer. Then we have this distributor module that's not on a redstone pulse, and it sends oak boats, which is what we happen to be using, and it will send it there and it will create a free space for here. So this is kind of confusing, but I hope you understand. And this modular router obviously just has a distributed module to cycle the next boat up here or memory card. And the same goes up. Goes all the way up. Right. And these activator modules, these are specifically filtered, whitelisted to memory cards looking downwards, right-click action. Make sure you whitelist them or it's going to try and use the boat and it will probably create lag. And then this one just goes to the next one. So that's kind of how the modular routers work. And then when you're at the end, the last one will end up sending everything up down to here. And when you hit this button, you should see the boats cycling now. So they'll cycle every so often and the memory card will travel upwards and it will rebind all of these. And it gets stuck back here. Perfect. So here we have effectively created our own interface P2P or pattern provider P2P. The pack creators chose to not include it in the pack, apparently because of unique automation, which this certainly is. I certainly haven't seen anyone do this before. There is one small catch to this. You will need some filler patterns in all of your pattern providers, just so that when you change a pattern, it can override it, because modular routers only have one interface slot, so they will need an existing pattern to change to a new one. The easiest workaround is, to create these dummy patterns, just name it filler and just fill up each interface. Just copy and paste the interfaces once, and you should just be done. It's pretty simple. Another thing I should probably mention is that it's pretty easy to add more pattern providers to the same setup. You could make the first setup using some wireless hubs and just make another module and connect that second module to those wireless hubs, and they will effectively be on the same arse lines. Super easy, and you don't have to go so far away. The other way I was thinking you could do it is putting wireless hubs directly on the arse lines, so you could connect those modules directly like that. So it's the same pattern and all of the things are consistent. But do as you please. It is fine. You can always add controllers if you want more channels, but I don't really see you needing more than 8 per subnet. Okay, so I just wanted to give a final setup and remark. I ended up finishing this monstrous build. We are going to be just testing it out. I have no idea if it's going to work or not, but let's demonstrate this parallel capability. So what we can do is, these are the patterns that we want in this array. So we can replace these filters here like this. So we're going to be crafting crystal mainframes and electric motors. We are going to press this button and then hopefully that will send this here and that will slowly convert all of these pattern providers. One small optimization you can do is you can put eco mode on these modular routers and that will slowly improve their performance over time, or I guess not over time, but it will improve their performance. You can see what it does. It basically, if the router is idle for more than 5 seconds, it will enter a low power mode and only run every 5 seconds. So you'll only be checking every 5 seconds. So it does make the check a bit slower initially, but it will speed up. And as you can see, all of these are getting replaced with their patterns respectively. The one thing with the setup is you don't want the arse lines to be running while the patterns are getting exchanged. It's not that much of an issue, but there is a chance that it could fill this singular slot in this entire array, which is a very, very small chance, but yeah, may as well try avoid it. But here we go. Let's go try craft some crystal mainframes. Let's do like this, do 2000, and then maybe we can do some ZPM motors, and we'll see if we can get this array running. Holy crap. Holy crap, this is running fast. Oh my goodness. Holy fuck. I did not expect it to be that fast, and obviously I've missed some of the wiring, but holy crap. That is absolutely absurd. Nice. I am glad we got it working, and I have a feeling that there might be some things I've missed, like maybe, oh yeah, these stream links aren't hooked up. I'll look at them later, but for now, this is absolutely insane. I think this will be fast enough. Just maybe. Just maybe. It looks like I'm going to have to sort out some power issues with these stream links, but I'm sure I'll figure it out. Oh my goodness. Well, if you ever want to parallel Arsline, I think this is the way to do it, to be honest. This is insane.